Hey guys, so this is my first recorded lecture over a PowerPoint, so I'm moving up in the millennial world. Anyways, so if you're watching this, I would have your Chromebook on split screen again in the little announcement I did yesterday. If you don't know how to do that, email me, or you can find it on YouTube. That is how I figured out how to do it. You can also Google it if you don't want to watch a video. But you need it on split screen so you can have the notes pulled up in a Word doc and you will be able to edit those. So, also, if it looks like I'm looking at crazy places, I'm either looking at me in the little tiny square or down at my laptop where I have the notes or at the computer where the actual PowerPoint is. So, I promise I'm not super crazy. I'm a little bit crazy, which you know, but yeah, that's why I'm looking around everywhere. And I talk with my hands just like I would in person. So, let's do this. So, for this one, we are going to be looking at our natural resources. Many of you have heard, read, talked about several of the natural resources already that we use. So, of course, we've got the stuff like the sun, we have water, we have stuff underneath the ground, we have wind energy. All of these things go under natural resources. So, what are our natural resources? So, the main three, so on your notes, the first three blanks here where it says Earth's resources include mineral resources, energy resources, and living resources. Those are the three you're going to put in the blanks right there. But there's also a couple other that kind of fall under those categories. So we have air, water, sunlight, and soul. Clearly, soul can be in mineral resources or it could also be in living resources, depending on how you swing it. Energy, that could be air, water, sunlight. And again, living resources, this could be like your trees, stuff you get that's living in the ground. But the three main natural resources of our planet is mineral resources, energy resources, and living resources. So, this picture here in the PowerPoint is also visible on your notes. For number 2 in the notes, it says resources are limited and are either renewable or non-renewable. Now, I know most of us have heard of those two terms before. Renewable is where if it's used at a steady pace, it replaces itself and it's never ending. And then non-renewable is a type of resource that once you use it and it's gone, it's gone. It's not coming back. You can't do something to make it reappear. A non-renewable resource, once you've depleted it, it's done. So, as you can see in this little graph here, and on your notes, we have renewable and non-renewable. So, renewable energy includes solar energy, air and wind, water and tides, and soil and plants. So, as long as all of these items are used in a way that doesn't like wipe out whatever you're doing. So, like, one example would be plants. If we don't chop down all the trees or take away all the plants, it's a renewable resource. So as long as we sustainably use those resources, renewable resources will be here forever. On the other side of things here, for non-renewable, we have the things that we're used to hearing from where we get our energy. So we have these energy sources here, fossil fuels, oil, coal, and natural gas. We talk about those a lot whenever we refer to non-renewable, especially coal in this region. We know that coal is an organic rock, not a mineral, because minerals can't be organic. So coal is an organic rock, and we use that for electricity. We also use fossil fuels for our cars, and oil and natural gas and stuff like that. But under non-renewable, we also have other things that aren't just like the liquids and oil and coal and all of that stuff that we're used to hearing about. We also have metallic minerals, iron, copper, aluminum. So those all come from the ground. They're mined in either ores or they find actual seams of these metals. And then you also have non-metallic minerals such as salt and phosphates. So all of these things, they take a long time to form. So since they take so long to form, like I'm talking hundreds of thousands to millions of years to form, since they take so long, those aren't necessarily renewable resources because me as a person, I'm not going to live to be 100,000 years old. And if I do, I will be studied by science. I will donate my body. I've already decided that. But there's no way I'm living that long. So, I mean, yes, these things are made again, but not in a time frame that is usable to us. So once we use these resources, they're gone. Let's see. Okay, so what are renewable resources? So renewable is going to be your first blank there on 3. Renewable resources. So renewable resources can be replaced by nature at a rate close to the rate at which they are used. So again, as long as we're using these resources at a sustainable rate, the earth can naturally resupply them, and we can use them forever and ever. So some examples of renewable resources. So vegetation. These are going to be crops, forests. This includes trees for lumber, paper, any of those paper products. So vegetation. So as long as we don't deplete the vegetation and just wipe it all out or wipe the seeds out, it's going to be a renewable resource. But vegetation also plays into the soil, because in order to have sustainable vegetation use, you have to be sustainably using your soil. This means you can't just keep having, let's say, specific farming practices that make all of your soil erode away, or you can't just remove sides of mountains and not place something there to hold the soil in place. So soil and vegetation kind of go hand in hand. And then another renewable resource is sunlight. We've got sun every day, all day, except whenever it's on the other side of the earth, whenever we have night. But then again, we still get a little bit of light from the reflection off the moon. So sunlight, air, we breathe air. And it's renewable until we do something that makes it non-breathable for us. And then we've already talked about soil, geothermal. Hopefully y'all remember me mentioning geothermal. So geo means earth and thermal means heat. So this is heat from the earth. A lot of people, in some of their houses, depending on how they set it up, they actually heat their water or air by having their pipes go underground to where it's warmer. And then it rotates through, it cycles through the house, and that's how the water or air gets heated. So in some cases, depending on the structure and how it's made, you can use geothermal heat. Then, of course, water. We know that water is broken up into salt and fresh. We can't necessarily drink salt water. We'd have to salinate it. But the fresh water, we know it's a very small percentage. But as long as it goes through the water cycle and it's not trapped somewhere and it's not contaminated, it's a renewable resource. And then, of course, ice. We know that a good proportion of the fresh water that we have is trapped in ice. So, again, ice is a renewable resource. You can use it, let's say, if you're living in the tundra, you can use it to store food. You could dig down into the permafrost and the ice. Or as the ice melts, we can use it for more water. So all of those are your renewable resources. Oh, I went down. Sorry, I hit the wrong computer. I hit my laptop instead of the keyboard. So what are non-renewable resources? Let's see. So for 4, in that first blank there, you will put non-renewable resources. So non-renewable resources exist in a fixed amount. Non-renewable are renewed extremely slowly or not at all. So like I said earlier, they are formed at a rate that's not sustainable to have continuous use of them. So just like with coal, right now, a lot of people are concerned we're going to run out of coal. There is still coal available to us, but at the rate we're using coal for electricity, and with the population growth and with how much each person uses electricity, that rising usage rate is going to deplete coal resources. So in that example, once we use it, it's gone until hundreds of thousands to millions of years later, whenever more coal beds may be formed. Maybe. Don't really know, because I'm not going to be around then. But, yeah, so non-renewable. They are renewed very slowly or not at all. So what are some examples of non-renewable resources? First one, coal. We talk about coal all the time. We've got oil, natural gas, petroleum, sandstone and gravel, salt, talc, graphite, sulfur, gypsum, uranium, phosphates, rock, potash, and nitrates, like potash is potassium, and other minerals. So we have all the minerals. We have some rocks. We have the gases and all of those things. So all of these things that we currently mine out of the ground in some form, they're non-renewable, because once we take them from the ground and use them, they're just not being continuously refilled. We're just taking them, and that's it. Take them out of the ground. Okay, let's see here. So these yellow ones here, will go in your blanks right there. So that's pretty much straightforward for number 4 in your notes. Oh, crap, I keep hitting the wrong thing. Sorry. Okay, so examples of non-renewable natural resources. So let's see here how this is going to play out on your note. So one example is talc and the other is graphite. Okay, so I mentioned briefly earlier that some of the metals that we get, such as iron and stuff like that, they come from an ore. So they aren't necessarily just produced by themselves. So the metallic element or valuable mineral part of a rock is known as the ore mineral. So that mineral that we're interested in, the iron, the silver, the gold, that's part of the rock, the important part is the ore mineral. That's what that mineral is. It's the ore. So that's going to go in your first blank right there. The metallic element or valuable mineral part of the rock is the ore mineral. So the remaining part of the rock is called the gangue or gangue. I don't know how to say that. That's how you spell it though. Gangue. So gangue. I'm going to say gangue. That's what I'm comfortable with. I'm going to say gangue. You can call it whatever you need to. So ore mineral and then gangue. And then some natural ore deposits that we are interested in. So one is copper ore. So copper, we're used to seeing it as what color? The color of a penny, copper. But it may look something more like this, because once copper is shown to other things, it can get this blue film on it. So kind of similar with iron and rust, but copper doesn't rust because it's not iron. Only iron rust, that's oxidation. But this may be something that you would find out while you're mining for copper ore. And then iron ore. Iron looks different. It can be very small. It can be in big deposits like this. But these are some of the ones that you would see if you're mining for ores. Oh man, I keep hitting the wrong thing. Okay, so mineral reserve. This is going to be your next blank on the PowerPoint. So a mineral reserve is a known deposit of mineral and ores that are worth mining. So this is like if you get a geologist to come and look at the stuff you have, they may tell you that there's a mineral reserve. So this means that they know there are deposits of valuable minerals in the ground. So this would be a term that people would have used whenever they were trying to buy land for the coal. It's like they know there's coal there, so they are telling these people that they want to buy their land because there's a mineral reserve. That's if they told them about it. But we'll just live in an ideal world and say they told them about the mineral reserve that was under their property. So natural resources, this is kind of a map of where these ores can be found. So we have zinc, mercury, nickel, cadmium, all these other things. So we know up in Canada, up near the tundra, we have a big iron deposit. In the southeastern United States, kind of around Florida, Georgia, Alabama, that stuff, we have lead mineral ores. And then you can see over here different elements pile up and form different ores in different places. So if you're really into world economy, don't know if you are as a ninth grader, but these deposits means that there are mining operations or other operations to get the stuff out of the ground, and they sell it. So over here, we have mercury, so they probably sell a good amount of mercury. So that kind of ties into their economics. So 5, non-renewable energy resources. So A, fossil fuels are non-renewable and may cause pollution. So this would be like the gasoline for your car or diesel and stuff like that. We use them in most likely a combustion form. So in the car, it burns the fuel, it releases carbon dioxide and other stuff out of your tailpipe, and it causes a pollution. They're relatively cheap and easy to extract. So examples like coal, oil, petroleum, natural gas. We've mainstreamed that, so it's pretty cheap to get to those items. And then another one for B on your notes is nuclear power. So some people don't necessarily think of nuclear power whenever we talk about energy resources, which is fine. Nuclear power is the energy created by atomic fission. So whenever we talked about the sun, this type of thing happened in there. So the largest nuclear reactor in our solar system is the sun. Fun fact. But on our planet, we just have power plants, nuclear power plants. So it produces very little air pollution because to release type of nuclear power, we force bonds of atoms to break. But as we saw in radiation, as we were calculating half-lives, it does produce toxic waste. And it causes radiation, and that's not very safe. So kind of like whenever you go to get an x-ray or some other type of scan, they always put something over your other parts of the body so you don't get that radiation. But it also produces toxic waste that takes millions of years to decompose because this toxic waste is radioactive. And we just talked about radioactive decay, and it takes years and years and years. It could even take a short amount of years, but it's not really short, or it could take a very long amount of years depending on what type it is. So nuclear power is also a non-renewable energy resource because once you cause it to do fission, it stops existing as what it was before that reaction. And then it continues to break down and break down. So it doesn't replenish itself. It just constantly decays. So the next one for 6 on your notes here. Renewable energy resources. So these have less of an impact on the environment and they promote sustainability. So this sustainability means the ability for future generations to have the same resources we do. So that's why they're renewable. As long as we're using them at a sustainable rate, they will continuously be there for us to use, which is what we want because I know way on down the road, my great-great-great-grandchildren, I want them to be able to enjoy air conditioner or, be able to charge their cell phones, be able to do all the stuff that we do today. So these include water, wind, sun, geothermal energy. All of these things are renewable energy resources. So number 7 on your notes, environmental cost versus economic benefit. So this is kind of whenever non-renewable and renewable resources kind of come into either a political or a social scene. So modern living standards are supported by extensive use of both of these resources, renewable and non-renewable. So we use a lot of energy. That's just what we do. We use a lot of energy. There are advantages and disadvantages to both. So it's like you're consuming something. So there's going to be something that happens because of that. And the extraction of some of these resources carries a cost on the environment. Coal, we talk about coal a lot. Let's talk about that. So it's very cost efficient to strip mine, which is just to take the top of the mountain off and do it that way. So that's very beneficial for economic reasons, but it's also not beneficial for environmental reasons. All of those animals that relied on that mountaintop for their home, it's gone. All of that soil disturbance is going to pollute the waters. There's going to be pollution from actually having all of that work done up there. So water is affected, habitats are lost, and it could affect several things downstream because of the water and chemicals that are being put into the ground. So extraction of several, not just coal, but the use or extraction of a lot of these resources comes with an environmental cost as well as economic benefits. So number 8 in your notes. Virginia has many natural resources. We've talked about a couple of them. I know some of y'all watched a video about kyanite mines, but in Virginia, the major rock and mineral resources include coal for energy, gravel and crushed stone for road construction, and then limestone for making concrete. So those are a couple of the things that our state has a lot of for natural resources. And of course, we make money off of these. So how does the way in which some resources are extracted and used affect our environment? So I already kind of talked about strip mining and, how that can affect a mountain. So it can lead to pollution, land, water, and air. It may contribute to global warming, and it destroys the landscape. So, of course, we have things in place now to where we can go and reclaim these lands and kind of make them usable again. But the initial act of extracting these is what messes with the environment. Let's see. So there's advantages and disadvantages for each energy source listed below. There's advantages and disadvantages. So fossil fuels, hydro, wind, geothermal, solar, all of these resources, they have their pros and cons. So you just have to decide which ones matter the most to you. And that's where the political and societal divisions come into play. So we've kind of already mentioned that we as humans, we use a lot of energy. We do. It's true. There's no hiding it because we just have all these things that we are accustomed to using. So here is a small breakdown of the energy consumption in the U.S. So we can see that we use a lot of petroleum. And we've kind of cut back a little bit on coal at 23%. Natural gas is a pretty big player. It's almost the same amount of usage as coal. We have nuclear. So nuclear produces a lot of energy, but it costs more to produce. So that's why we don't necessarily use a bunch of nuclear energy as opposed to the other things. And then again, we have electricity imports and then renewable energy. So renewable energy is only 7%, but it's made up of several different things. And that's something that a lot of people want to kind of move more towards because these other things are non-renewable. So also on your notes, there's a couple definitions that you need to look up. They're pretty simple. You can Google them. You can use your own words if you already know them. Those words are going to be conservation. Conservation is where you do certain practices to conserve these resources. You know what an environment is. Fossil fuel, we talked about that in the PowerPoint. And then recycle. So make sure you fill in those definitions and then also list 4 ways that you feel like you can help protect the environment and make sure these natural resources are here for a long time. So that is the lecture for natural resources. Here in a little bit, most likely after lunch, I will be recording the next PowerPoint that was also supposed to be done. So make sure you fill in these notes on your Word doc. And if you have any questions, please email me. Or if there was something in here you didn't really understand. Or if you're just like, Miss Williams, you went way too fast. I have no idea what's going on. I need you to go back. you let me know. You can comment on here, or you can email me, however you feel like doing that. But so natural resources, it's something we rely on. It's something, it literally makes our society work. All right, guys. See you on the next video.